So today in this video we will see why square root of 2 is irrational number. It's not a rational number, it's irrational. As you are aware, real numbers are the numbers which are rational and irrational numbers, and rational numbers are those numbers which can be denoted as p by q, right? And where p and q are the integers, right? But irrational numbers, they are non-terminating after decimals, right? And they cannot be represented as in this format p by q, right? Okay, so let's see how we will prove that why square root of 2 is irrational, right? So when I say irrational, so it means it cannot be expressed as in the form of p by q, right? Where q should not be null, right? This is a format of a rational number, right? Okay, so we will use the concept of proof of a contradiction, right? In which we will assume that square root of 2 is rational, right? So when I say rational, so it means that it can be represented as p by q, right? Let's assume it, right? At this moment, let's assume that p by q is this number is a rational number, right? And it can be represented p by q. The thing over here is that p by q do not have any common factor except 1, right? Because if there is any common factor, we can easily cancel it, right? For example, if it's common p by 2 or 2 by 2, so it can be easily cancelled. So p by q are do not have any common factor. It means they are prime numbers, right? The one is the only common factor. Okay, so let's do one thing. Let's square it at both ends. Okay, so it would be p square by q square, right? So it means it would be 2 into p square by q square. Okay, now if I do this, so it would be 2q square equals to p square, right? Now if you can see that p square is 2 is the factor of a p square, right? If I can write it over here, is that p square, right? So 2 is a factor of p square. It means 2 can divide p square. It also means that p is also 2 is also a factor of p, right? So we know that, right? So it means p can be written as, say, assume that 2 into some element k, right? So it means 2 is a factor of p. Okay, so let's replace this with q square. P over here, from p we can replace it as 2k square, right? So it means that 4k square 2q square, right? And then q square would be 4 divided by 2k square, right? So it would be, it means 2k square. So now you can see 2 is also a factor of q square. Okay, so it means that 2 is the factor of q, right? 2 is the factor of q, right? If it's if q square is a factor of 2, it also means that 2 is a factor of q, right? Now you can see 2 is a factor of p, and 2 is a factor of p also, and 2 is the factor of q also. So it contradicts the concept, right? Earlier we started, right? P and q both are the prime numbers. It means that they do not have any common factor except 1. But now you can see p and q both have a common factor 2. It means that the thing which we have assumed initially, that square root of 2 is a rational number, is incorrect, right? It's incorrect, right? So it means that it would be a irrational number. Okay, so thank you friends for watching this video. Thanks for watching this video. If you have found this video useful, please do like this video and subscribe to our Maths Grow channel. Thanks again.